Hey everyone, and welcome back to the Firefighters podcast, where we seek to develop, inspire, and motivate the world of the emergency services operator through a series of wide-ranging conversations. Now, before we go any further, just hit that rate, follow, or subscribe button on whatever platform you're listening to. It's a key performance indicator for us and helps us reach even more people. Now, here's what we've got for you today. Okay, let's go. Welcome back to the Recruit series, Firefighting Foundations Fundamentals. If you're tuning in, you're continuing your journey from firefighter recruit to well-informed, tactical, competent fireground professional. That's the plan. In episode 1, we introduced the foundational ideas about fire behaviour. Now we're diving a layer deeper into some of that molecular world where fire truly begins. That's chemistry. So today's topic is basic chemistry for firefighters, because if you don't understand what's happening at a chemical level, you're just chasing flames, which is a lot of fun. There's a heck of a lot of tea and medals and high fives and memories and photos to be had there, but you might not be as effective as you could be. So what is fire really? Let's start with that really simple question. What is fire? Fire is a visible, tangible result of a chemical reaction called combustion. This is a rapid oxidization of a fuel. Okay? Rapid oxidation of a fuel, producing heat, light, and a range of gases and particulates. So what does that mean for us? Fire is basically chemistry in motion. And if we understand the components that fuel that reaction, we can interact with it, we can manipulate it, we can gain control over it. So the building blocks. These are atoms, molecules, elements, and compounds. So let's scale it right down. And again, for all of you science buffs out there, forgive me. Atoms are the basic units of matter. Think of them like Lego bricks of the universe. Elements are substances made up of one type of atom, like oxygen or carbon. When atoms bond together, they form molecules. 2 hydrogen atoms and 1 oxygen atom is, say it out loud. If you did it on your own in the car, you're a loser. It's H2O, it's water. Okay, 2 hydrogen atoms, 1 oxygen atom. When atoms from different elements combine, they form compounds like carbon monoxide or acetic acid or something like that. These are the things we encounter in smoke, gas buildup, or during overhaul, or during damping down and turning over. Overhaul for the American listener. Now, why should a firefighter care? Yeah, and Pete, this is the second episode you're doing this. It's getting a bit technical. I'm bored. Because the products of combustion, many of them toxic, are just combinations of atoms and molecules reacting under heat. Knowing what's in that smoke, what fuels are involved, and what gases might be present can help you assess the risk and make tactical decisions a little bit faster, okay? So, fire triangle, chemical reactions. Now, you've probably seen the fire triangle. You probably saw it as a kid. It's heat. Say the next one. Fuel, oxygen. Great. Take one away, fire dies. Yeah? Add one in excess, especially oxygen, and the fire behaves very aggressively. But it's not really just a triangle anymore. There's a fourth side, a chemical chain reaction, which creates a fire tetrahedron. Okay. And I might be losing some of you here. Tetrahedron, we didn't teach it in primary school because it's a hard word and I can't really even spell it. That chain reaction is what allows fire to sustain itself. That's what we're interrupting when we actually apply water, isolate fuel, or manage ventilation, okay? As a firefighter, you must see these components dynamically, not as a checklist, but as a fluid reaction you are working to manipulate or interrupt. Okay, let's go with combustion, oxidation, and fire behavior. So combustion is oxidation. That's a fancy way of saying material, typically carbon-based, reacts with oxygen, and in doing so releases energy in the form of heat and light. Okay, it releases energy in the form of heat and light. I'll say that again. That is an exothermic reaction because it gives off energy. Exothermic gives off energy. But not all oxidation is combustion. Rusting, as an example. You leave something outside all the time, that's oxidation is all okay, but it's really slow and doesn't produce flames. Our interest lies in rapid oxidation, which generates intense heat, aka fire. Okay? Different fuels oxidize in different ways. Wood chars and burns and glowing embers. Plastic breaks down and produces like dense black smoke. If you've ever seen a washing machine on fire or a car, full of toxic gases, hydrogen cyanide, carbon monoxide, nasty, nasty stuff. This is when we say fire changes, because the stuff that was on fire 50 years ago is different to the stuff that's on fire now. So we've said exothermic. Let's break those a little bit down. So exothermic and endothermic. Exothermic reactions release energy. That's fire. Endothermic reactions absorb energy, like water evaporating or ice melting, something like that. This is what you should get. We apply water to a fire. We're using an endothermic reaction to absorb the heat energy from the exothermic process of combustion. We're trying to be an energy thief. That energy trade-off is the science behind every suppression tactic, really, pretty much. Get it right and the fire is not back. Get it wrong, apply too little, too late, or in the wrong format, and the reaction continues. So let's talk a couple of tactics. I'm not going to get super deep. There's lots of examples from previous guests, but let's talk a few tactics. Ventilation and like timing when we do it. If you open up a window or a door too soon in a ventilation controlled fire, you inject more oxygen into the exothermic reaction. More oxygen equals more oxidation equals rapid fire growth. You're fueling the chain reaction instead of actually stopping it. Okay? Very simple example. So inside a compartment, those rising temperatures and accumulating gases are part of a self-reinforcing exothermic chain. Yeah, it's self-perpetuating. It keeps going on. If enough fuel-rich smoke is present and oxygen is suddenly introduced, you get the backdraft. Yeah? This isn't just about flame. It's about chemistry in transition. Okay? Legacy furniture made of solid wood burns a little bit slower. Today's synthetic materials, like I've just said, they release high energy compounds really quickly. You're not just fighting a fire, you're managing a chemical event with a higher heat release rate and a toxic load. We've covered a lot there. So final thoughts, if you're serious about being more than just the hose dragger, you need to understand the chemistry happening behind the branch, okay? It's not just academic, it's operational, in my personal opinion. Again, this is only episode 2, stay with me. When you understand exothermic and endothermic, hopefully you can visualize oxidation and combustion. When you realize that each molecule of smoke is a potential warning, you're ready to lead on the fireground, because you're not just experiencing this event, you're actually looking for signs and signals and indicators, and you'll be better informed to take action on it. Next episode, even more tools into your tactical toolkit. So until then, go through it again, stay smart, stay safe, enjoy yourself, and I'll see you on the next one. Well, that's it for today, folks. Hope you took a lot away from that episode. We started the Firefighters podcast to develop, inspire, connect, motivate, represent, and most importantly, celebrate the world of incredible emergency services operators and the wider sector through this series of wide-ranging conversations. We really love creating this podcast and bringing it to so many people. Did you know you can also find these on YouTube? We do a lot of video podcasts now. You can head over to our YouTube page and follow, subscribe there. And as a final ask from us, whatever platform you're on, please rate the podcast. It really helps us as a key performance indicator to reach more and more people. I've been your host, Pete Wakefield. This has been the Firefighters podcast. And wherever you are in the world, please stay safe, be happy, live with intention, and where possible, please remember and support your firefighters and first responders. I'll see you next time.